we're going to talk on a subject this afternoon which is usually not talked about in universities, but actually is at the heart of a university education. The underlying assumption of a university education is that what they learn at university is something that they will be able to transfer to different contexts after university, whether that context is in a for-profit organization, whether it's in a non-for-profit organization, or whether it's in an academic institution or a government institution or wherever. And so the idea is that they can transfer their knowledge. I do not know if you're familiar with the research on the transfer of learning, but the research on transfer of learning indicates that human beings are remarkably lousy at the transfer of knowledge. They don't do it well. One of the reasons that they don't do it well is that their education doesn't prep them to do it well. Why is that? Well, if you're going to transfer to another context, then you actually have to transfer to another context. If that's the outcome that you want, then as we've been saying consistently, one of the best way probably to achieve that outcome is to practice it. That is, to put it to work in a different context. And yet we spend almost all of the time applying it in an academic context. Now, some of our students will go out on internships, so they get a chance in an internship to experience a novel context. However, most of the internships don't usually give the students challenging technical responsibility because the company has other more experienced people to do those challenging technical responsibilities. But regardless, our students are rarely placed in a situation where they're held accountable for the transfer of learning. Okay? And in some cases, we feel guilty about putting them in a situation where they are responsible for the transfer of learning. We don't think that's kind of fair. One of the reasons that I think we don't think it's fair is that human beings turn out to be lousy at it. And so when we do try it in the situation, students do poorly at it. They're not happy with the poor performance. We're not happy with the poor performance. And so we'll go back to something that will perform better. But ultimately, university education should prepare a student to transfer their learning into novel contexts. Now, there are kind of two elements to that transfer. One is understanding the metacognitive elements of it. Now, we just got started on metacognition the other day, and people were pretty clear in their responses to the muddy point that they didn't quite understand metacognition, and that's kind of understandable. We didn't do much with it yesterday, so we're going to do a little bit more with it today. And the other thing is that we actually try to teach with the objective that our students will be able to transfer. So we're going to try to look at both of those things today. So this is just a reminder. I should have switched in there. You would talk to Dr. Monrell for a copy of the thing. I forgot to paste that in there. We are in the session on designing a course to promote transfer of learning, or designing learning experiences to do that. And we're going to look at metacognition. When I mentioned metacognition yesterday, and I referred to an example on integration, I was meaning this example. This is there's this article that's quoted at the bottom of there. I think it's one of the best articles to help non-learning scientists or non-cognitive science understand metacognition. So if you look at this problem and you want to integrate the problem, it turns out that you can do it at least three ways. One is to recognize that the numerator is close to the derivative of the denominator, and with a little bit of manipulation, you can get the numerator to be the derivative of the denominator, in which case you just got a dx over x situation. Now, you could also treat that as a partial fraction expansion, We can factor the denominator, and we can do the partial fraction expansion, and then we can get the coefficients, and then once we have the partial fraction expansion completed, then we're in a good shape to actually just generate the integral, because we can do that from a table. The third way to do it is with trigonometric substitution. You can look at that, generate the right trigonometric substitution, and you can end up with another correct answer. However, each one of those methods takes a different amount of time. So the content in terms of integral calculus is knowing that there are three different ways to integrate that expression. The metacognitive knowledge is drawing on and saying, well, which one of the three would I do? I would run some quick estimate. I would look and say, gee, if I were going to do it one way, it would go this way. If I were going to do with a partial fraction expansion, I have to do a little harder to get the partial fraction expansion coefficients. If I'm going to do a trigonometric substitution, I have to do a little more work to do that. I should decide that I'm going to do it the first way, metacognitively. On the other hand, you could have another set of metacognitive rules, which basically says, I look at the expression, the first thing that pops into my head is what I'm going to try. And now you're in a roulette reel. The roulette reel has three parts. You spin it, and whatever method of integration you happen to randomly hit on, that's the one you do. Now that's a different metacognitive strategy than saying, are there different ways to approach that, and are there more time-efficient ways to approach it? So one metacognitive strategy is just try whatever comes to mind first. The other one is to take a slightly more planned out and elaborate approach. On one hand, the planned out and elaborate approach sounds a little more time-consuming because I have to lay it out. It would be much faster that the first thing goes if I just pick it and go to it rather than actually do any kind of planning. All of that stuff is all metacognitive strategy and knowledge. The idea that there might be three methods of integration is the integral calculus part of it. Recognizing how I'm going to approach it, recognizing that there might be multiple approaches, recognizing that I may want to consider which of those multiple approaches to use before I actually adopt one rather than making a random choice, is all metacognitive. And that's the difference between, in this case, the domain knowledge that I need is integral calculus. The metacognitive that I need is a question of planning about how I'm going to go at it. And as the author says, when they composed the test and when they ran through the time that it took the test, they did it by the first method, which is to recognize you got a du over u situation, and that goes pretty quickly. However, if they happen to run it using one of the other two situations, it takes considerably longer, and that kind of blows up the faculty member's analysis of how much time the test is going to take. Again, not due to any question about metacognitive, any question of the knowledge of integral calculus, because any one of the three answers gets you to the same point. It's a metacognitive question in terms of what's going to be temporally more efficient. Generally, when we give problems to students, our metacognitive reasoning is so tightly embroiled in how we approach the problem that we don't even we don't even realize that it's going on. Two, that it may be the result of considerable expert practice. And three, it may be the result, if you're working on a final exam, the fact that you made the final exam so you already know how to work it. And so typically, faculty members don't consider the metacognitive work that they do because it is either hidden from them or something that is obviated, not necessary, because they've just done it so many times that I don't need any metacognitive knowledge. I just recognize the pattern and shoot it. Okay. But if our students are going to be successful in the test, they will often have to deploy their metacognitive strategies and knowledge, and many cases that's weak. Because if you look at our curriculum, I'm going to hazard a guess. I'm going to assume that if you looked at the undergraduate curriculum for any student at IIT Bombay, you will never find a course on developing metacognitive knowledge and strategies. And yet the success of the student in any course could depend on that. So it seems an unusual curricular design. So this violates one of my general rules for designing a PowerPoint slide, which, as somebody pointed out in comments, it says he makes too many PowerPoint slides with lots of text and no pictures. This is an example of a PowerPoint slide with lots of text and no pictures. Nevertheless, that it's a story. And I'd like you to read the story about Josefina. So I'm sure you'll give me some visual feedback when you've comprehended the story. Here's a second story about a different student. So I'm going to pose the following question to you. Let's assume, for the sake of this question, that Josefina and Maya are both equally adept at the domain of the course that they're teaching. The test score may not have shown it, but let's just assume that. Which student would you prefer to teach? Why? What distinguishes Maya?
He's not bothered about the exam score.
That's not quite true. She says she's not too worried about it, but she does seem to be slightly concerned about it. Yes?
I think she has the right approach towards learning, which is to try and figure out what where her confusions are, to try and get her peer group to clear them. And I'm quite confident that Maya will go on to have a kind of, will be successful in whatever she wants to do. So
Yeah.
that's the reason that I would want to engage.
So how would you distinguish Maya? This is cold calling, by the way. How would you distinguish Maya from Josefina if we agree, for the purpose of the conversation, that both Maya and Josefina are both equally adept at the domain knowledge? Oh, that's for Sai. He says, I would prefer, I'm saying, what's the difference?
How would I differentiate them in a classroom? Is that what you're asking?
How would you explain the difference? You said you would prefer to teach Maya.
Yes.
You like the way she would approach things. What's the difference?
Exactly.
Not how she approaches things. What's the difference?
What's the difference in what? Sorry, I don't understand.
How would you? So they approach something differently.
Yes.
Why? This is hypothetical. Why do you think they approach things differently?
Perhaps because Maya's interested in the material and Josephine is interested in the grade.
Okay. Well, somebody else. Yes.
I think Maya has a way of self-evaluating and having a good idea of whether she understands or not.
Okay.
And that is the key thing, and that makes her a better student, because most of the responsibility now from the instructor has shifted to the student herself.
Okay. Has anybody got a better explanation? Person in the back.
I think Maya was more regular, whereas Josephine sort of bundled it all up in the last 2 days. So that's the difference.
Yes. She has a better learning. Got to wait for the talking stick. You don't get to talk without the stick there.
She has a better learning method.
Why?
Because she is giving herself opportunity to think and process what she learned in the class. So
Okay.
she's taking it at a deeper and higher level than the earlier girl. Although intelligence-wise they might be equal, but the net result of learning is much better with Maya.
Well, the Maya is better because she takes it as the job during office hours, whereas Josefina takes it as learning as a after office hours activity.
So let me put it differently. So people are telling me what Maya is doing, but they're not quite getting at why Maya might be doing these things differently.
Because she's getting more questions.
That's telling me the difference in action, not the difference in cognition.
So,
okay.
How is Maya thinking about learning differently? Yes.
So it looks to me that Maya is probably thinking at a level higher than just the material. I mean, she's kind of looking at a level higher. There is I don't know what to call it. I mean, probably.
That would be called metacognition. That's called the level higher than the cognitive level. Yep. Okay.
Or incremental learning can be called as, this Maya is learning incrementally, whereas the other ladies.
Again, you're telling me what she's doing. You're giving me the behavior. You're not telling me the cognition behind it. What I'm driving at is Maya has better metacognitive knowledge than Josefina. She has a better picture about what learning is than Josefina. Now, and she acts on it, but she acts differently because she characterizes learning differently. She characterizes learning as a process that is ongoing, one that requires, as somebody said, self-evaluation, a continual process of self-evaluation and figuring out what to do about it. Josefina characterizes learning as an epic event. That is, we only kind of do it occasionally. Learning only happens occasionally. We only work at it occasionally. It's an epic event. So we have these completely different pictures of learning, and that's part of a metacognitive distinction. As somebody said, it occurs at a higher level than the subject that they're studying. Now, she may have, and we say, oh, well, that's better. Well, that's good, but the part of the question goes, well, where did Josefina ever get the opportunity to have a different picture of learning? Yes, sir.
Could it be that Josefina is actually, she was better so she could understand and absorb the content, and therefore she was confident that she'll be able to just revise at the last minute and go ahead? It could be that she has been learning throughout and absorbing better in the class, and Maya was not able to follow, because of which she had to read.
No, but it's just the way now, she may have thought that she could do that, but she still characterizes learning as kind of this, do it now, do it this time, and we don't do it. Josefina characterizes, her past experience could have said, learning is this kind of, we do it just in this kind of concentrated period of time, but that's again her metacognitive picture. And it's wrong. And Maya has a different metacognitive picture of learning, which is something that it occurs on an ongoing self-evaluation basis. And the question then is, where did Josefina ever get a chance to correct her misconceptions about learning? Okay? Learning is not always a question of, gee, it worked for me, therefore that's how learning occurred, because you could be right. Josefina could have studied in high school or pre-college and found that it worked for her. Just because it works for her doesn't mean that it's a good way to go at it.
So if I understand your question correctly, it's sort of both of them had the same set of resources, but Maya sort of managed them better, maybe because her approach was different, and then we are trying to understand what about the approach was it that sets her apart from Josephine. So one thing I notice is there is this comment on this peer group which Maya mentions that she sort of found that to be quite helpful, but now she's here meeting the instructor because there are some things which did not get resolved there. Whereas Josephine does not comment about those. So maybe Maya sees, so maybe Josephine sees them as just a checkbox of things that are meant to be done in the course, but Maya sees them as a sort of resource that is supposed to serve a particular purpose, and she's using it for that, and now she feels that is not adequate. So it's the attitude, I think, which is slightly different. Maya sort of has this awareness of these things being at her service, and she should use them in a certain way. Or maybe I'm drawing too many conclusions, but I think sort of that is what I'm trying to get at. Just the approach to how to use things in the course.
So I would agree with you that her approach is different. I would disagree with you in terms of her attitude. I don't think her attitude is necessarily different, but I don't know whether her attitude is different or not, but I do know that her approach is different, and I also know that her approach comes closer to being based on the research on learning than the question of Josefina. So both of them have impressions about how learning works. One of them happens to actually be closer to the question of how learning works than the other. And then the question becomes, if the difference in approach to learning makes a significant difference in the outcome, then where are our students supported by getting knowledge and appropriate practice so that they learn to approach learning more effectively? Because Josefina is pretty sure that she's approaching learning effectively. It could have been based on her past experience that this has always worked for her in her past, but she is not pursuing a research-based approach to learning. Her approach to learning from a research standpoint is really bad. Now, it may have worked for her in the past because the expectations for her achievement were low enough that she could clear them. And now when we raise the bar, we aren't getting there, and we attribute it all to, well, she just doesn't know the subject. Well, no, look at them. The distinction between them clearly looks to be significantly different in terms of their approach to learning. Oh, I got talking sticks. Yes, sir.
Yeah, so does it have to do with retention of learning? Like in case of Josefina, she might forget everything that has been learned immediately after the exam because it was,
nope.
Whereas here it may be retained for a longer period of time.
That could be no, it doesn't have to do with the retention of learning, it has to do with the approach to learning. Now the approach to learning could result, better approach to learning could result in better retention.
Yes.
But what we're seeing here is not retention, but approach.
But sorry, last word?
We're not seeing retention difference, but we're seeing an approach that's
different. Difference, okay.
Yes.
Is Josefina's goal to clear the course? Just that? And is Maya's goal different?
All of which is metacognitive.
Yes. Because, she wants to clear the course and that's what she's doing. This
no,
girl
she's
wants
not.
No, not Maya.
No, Josefina is not.
Yeah, but...
Josefina's goal may be trying to clear the course, but
Correct.
she's clearly not pursuing an approach that will allow her to do that.
But her goal, it appears to me from what I read, is, she's not put enough effort, she goes the night before, all of that I read. But I think this Maya's is more a learning exercise, like lots of us here want to clear the course, because we can go then to the next level.
Right.
While there are some who would want to imbibe everything in the course so that they learn some more and they want to use it differently.
I understand what you're saying, but I think this is not. So I understand that you have people that say they just want to clear the course.
Correct.
But even the people that just want to clear the course are not pursuing an approach that actually is effective at clearing the course. And so to me, what you see in difference here is not a course goal, but a difference in terms of how we're approaching whatever goal we're after.
Okay.
Maya clearly is pursuing an approach, and this is one of again, Maya's clearly pursuing an approach that's supported by the research on learning that says her approach will be more effective. Josefina is not pursuing that approach for, and at least one of the reasons may be, although, is that Josefina may not be familiar with the research on learning and what an effective learning approach looks like. Now, she may just have, you may be right, that she may just have the goal of clearing the course, and Maya could be, I want to suck up and get everything. However, in the story, what we see is very different approach, and where we like Maya's approach is, I would suggest to you that it's much closer to what is supported by the research, and what I'm asking is, where do our students at IIT Bombay have access to the resources so that they could actually know what a research-based approach to learning looks like? Now, they may choose to ignore that, just as if, telling you that POGL is a far more effective approach to teaching than traditional lecture, and you may still choose to say, no, I'm going to teach with a traditional approach. That's your choice. But you at least have the information and the knowledge to go and say, oh, there's a different approach available. Now, Josefina may not have the knowledge and strategies to know that there's a different approach available. Now, another story could be, yes, she knows all of that and still says, no, I prefer to cram it on the weekend because, as one person suggested, that's been effective for her in the past, and I'll only do what's been effective for me in the past. Okay? Yes, sir. You need a...
So, informally, by default, some of this happens in the hostels and the dorms where the students are. Mm-hmm. Formally, I don't think it's something which we, at least I've never had the opportunity to engage in it or to actually, let alone be a part of my design.
Okay. Now, so I've heard people talk about, and they use those two words. Well, informally, this happens, and formally, this happens. Okay? My problem with those two words is that they convey a sense that, well, either way is okay. Suppose we replaced formally with randomly, and informally with randomly, and formally with intentional. Then we go, oh, one occurs at random and one occurs intentionally. Which do we prefer as an institution? I mean, there are people, we have this question in terms of mentoring faculty. There are faculty that link up with the appropriate mentors and sort it out, and there are faculty that don't. I would suggest to you, and they would say, well, that kind of occurs informally. I think if we replace that word informally with randomly and the other one with intentionality, then we would make it much more a subject that we think about doing something about instead of, well, that's just not something we touch. So, yeah. So, with that background, these are the kind of things that I think you should be able to do at the conclusion of this section. So the first three are at the understand level in Bloom's taxonomy. I'd just like for you to be able to talk to yourselves and say, when we're talking about metacognition, this is what I'm able to describe it to a colleague. I'm able to describe transfer of learning to a colleague. I'm able to explain to a colleague why it's important that we ought to think about metacognition. Now, the next two are more, well, suppose that I was charged with promoting metacognitive skills, what would I do? That's much more of, could be an apply level, depending on if you have something and says, these are general things and you have to put it to work in your class. That's an applied level. You may feel that you actually have to create approaches to promote metacognition, in which case that would be at the create level in Bloom's taxonomy. But these are the things that I hope the workshop will facilitate your development with respect to. So when we get, this is the point where we kind of left off yesterday. Metacognition, when it comes down to it, and people alluded to pieces of it before, comes down to 4 things. It comes down to self-assessment. Maya would look at what's confusing to her, monitor how it's going, and take corrective action. She went, this is confusing to me. Doesn't seem to be getting any better. I better do something different about it. And then does something different about it. So I actually had a chance to teach an integrated curriculum, and we had the freshman students using a computer algebra system. And we gave them assignments on the computer algebra system on Friday, which was their first day in class. And we gave them an assignment over the weekend. And a number of people on Monday reported the following kind of story. These were very diligent students. I said, I worked for 30 hours over the weekend, and I didn't get these problems solved. Now, I don't know exactly what happened for each of those individual students. My concern is that the following picture occurred. I tried the same thing over and over again for 30 hours with virtually no change in what I was trying, and it didn't work. And that would be no self-assessment, no monitoring, and no correction. That is, I just keep on trying the same thing. It's like I have a program that doesn't work, and I'm going to keep compiling and running it and finding out that it doesn't work. Okay, we're not too keen on that approach there. It doesn't have any self-assessment, monitoring, correction. Second element is task identification. What kind of things are we facing? Do we understand the nature of what we need to do? So Maya was using a strategy, sometimes task identification. If I've got something confusing, one thing I can do is take it to a group of peers and we can talk about it, and maybe that'll clear it up. Maybe this is kind of a task that can be cleared up by a group of peers. But as somebody else pointed out, occasionally Maya would find that nobody in my group of peers is able to help us figure this out. We can't figure it out together, and so we go to either the TA or the instructor in terms of office hours. That comes back to task identification. We're kind of getting a handle on the nature of the problem, and we're kind of getting a handle on what it's going to take to resolve it. Going on with, as really part of corrective action, but it's often called out separately, is kind of planning and strategy selection. How are you going to go at it? Josefina had a strategy selection that suggested that all of the work in prep for an exam could be done over the weekend. Maya took an approach that says, no, we're going to kind of continue to come at it on a day-by-day basis. And finally, the last thing is a little hard to convey. It's the organization of what you know. So the best literature that I can direct you to on this is there's a whole set of literature called expert-novice comparisons. Don't know if you're familiar with that, but for a long time, cognitive scientists did a lot of work and said, what characterizes the difference between a novice and an expert? Now, and therefore they would study both. Now, one of the places where a lot of work was done initially, partly because it was kind of relatively easy to access, was they studied what's the difference between a chess grandmaster and a chess novice. So I'm going to give you So in one case, for the chess grandmaster, they had an arrangement of pieces. Now in chess, you have approximately 32 pieces. And let's assume that a good majority of them were on the board, and they would place them on the board. And they put them on the board, and they asked the grandmaster to look at it. Grandmaster looked at it for a very few seconds, and in position A, looked at position A in very few seconds. Then they stopped showing him position A when they said, please place the pieces on the board. And grandmaster could put the pieces on the board without error. Wham, 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 wham. They showed another position, position B, and with roughly the same number of pieces, or roughly the same number of pieces. And then they showed it for a few seconds, took it away, and they said, can you put the pieces on the board? And the grandmaster had little or no success. So what was the difference between position A and position B? They were both arrangements of chess pieces, one of which the grandmaster easily reproduced, the other which the grandmaster didn't. Now, if you're familiar with the research, then you can't answer this question because that's cheating. Okay. Yeah, what's your guess?
Maybe it was a pattern, like one of those standard patterns that they recognized the first thing. So my guess is the first one may just have been a pattern sort of with some standard name that the grandmaster is aware of, but the second one was just some random arrangement of pieces.
Okay.
Or you might have got the logic of the arrangement of those pieces, logic behind the, or plan behind with which the one would have arrived at that positioning of pieces. So
Okay.
he could.
Any other ideas there? Yes, other idea. You notice that the people that are talking are only still the same group that people talking. The silent people have hardly said anything. And that's part of the reason that, you didn't call on volunteers, but we're violating that modeling rule. Yes.
My guess is that the grandmaster started working on the first set of pieces, and in his head he's already working that out, and giving him a new arrangement he doesn't know.
He had both the same time to look at them. Right. So the difference was, you had a...
It could be just illegal positioning of the...
It takes forever to train people that they can't talk without a talking stick. But
it could be illegal positions.
So I would say position A came about because it actually resulted from a game of chess that was
Correct,
played.
yeah.
Position B was just a random piece of the board. And so the grandmaster could look and go, okay, I've played enough games or whatever. Yeah, I'm okay, yep, man. This random piece, I don't know, how do they, you probably looked and said, they can't end up that way or whatever. Okay? But now the novice or whatever would approach A and B almost on the same level. Their ability to reproduce A and B was the same because they didn't recognize how these pieces in A got to be there. There was no kind of mental picture of how such a situation could arise. Grandmaster probably looked at it and said, well, that arises from the opening. That's 30 moves into the opening from Catalan's version, whatever. Okay? But it all came about because Grandmaster had experience with certain patterns that emerged from real games and wasn't too good if you just gave him a set of random pieces. So there's clearly, in terms of organization, experts have codified a lot of things and they put it for easy retrieval. This has been demonstrated in physics. Okay? If you get novices in physics, when they look at a physics, when they're given a physics problem or whatever, novices will look at the physical features. Oh, they'll say slanted surface or wheel or a pulley or whatever. If you show it to a physicist, they may even not even be able to tell you that there's a pulley in there. There's, conservation of energy. Just, it's not a question of knowing the concept. Both of the people could probably return to you the definition of the concept. It's a question of how they have organized all of their knowledge so that when they see a new situation, they think about it in entirely different terms. Now, this is one of the reasons why I don't think the term understand helps, because the physicist would say the expert understands. But the novice would go and say, but when you give the idea of how you are organizing the knowledge, I think you're helping people to see what a more concrete way in which the thing might be distinguished. And people can work explicitly to reorganize their knowledge and say, okay, start thinking about these things. You've learned about the concept of energy. Now, every time you see a situation, ask yourself, how is this energy? How does energy help me think through this? How does energy thinking about this clarify the situation? So forth. Yes?
So, one of the phrases that we use is reading between the lines. So would this be?
I can tell you by looking at several textbooks, there's nothing between the lines.
11.
So I understand the colloquial phrase reading between the lines, but for the novice, when you say read between the lines, and the novice looks and goes, "There's nothing between the lines. So what are you asking me to read?" Yes, I think, again, I don't think it's reading between the lines. I think it's taking your past experience and reorganizing it around an entirely different set of ideas. So both of them, both the novice and the expert, may be able to tell you the textbook definition for energy, but the expert has long reached the point where they go, energy is a way to help me categorize a bunch of different situations. The novice, while being able to explain to you the idea of energy, never thinks of energy as a way to reorganize their knowledge. Earlier, it was mentioned that the idea of research-based instructional strategies versus evidence-based instructional strategies, the difference between those seemed vague, and that's because it is. Most of the time, you can consider those things to be synonymous. But you'll also see people writing in this area. In addition to writing on metacognition, they will write on self-regulated learning. They will write on reflection. While they may describe those terms, metacognition, self-regulated learning, and reflection differently, they're sufficiently closely related that I would encourage you to think of them as a package rather than to get too caught up in the fine distinctions. So remember our first learning outcome. So I'm hoping that this kind of conversation helps you in your ability to describe metacognition to colleagues. Studies that have been done can correlate improvement in metacognition or self-regulated learning with improvement in cognitive abilities in subject areas, which suggests that you can get improvements in the kind of test scores and project scores you want, not by concentrating on more of the subject, but you can also get improvements if you can improve the student's metacognitive abilities.
See, for a long time, I don't know, even now people talk about intelligence quotient. I don't know how relevant. IQ, yes. And, or maybe, so I'm just curious, what is so does this anyway correlate with what people call intelligence quotient? And do we even accept the idea of an intelligence quotient as one number today? And, does a higher level of metacognition indicate higher IQ or vice versa? Because, when some people say, well, if you have a better IQ, then you are likely to do better academically. That's one view.
Mm-hmm.
So now, where do we stand in this?
Well, the best answer I can give you is I don't know. We still have, there are still recognized IQ tests. And in the United States, we created something called the Scholastic Aptitude test. And it was supposed to measure aptitude. Now, underlying both the SAT and an IQ test is the assumption that they are measuring something inherent in the individual. And that assumption, I think, has largely been debunked. In other words, because particularly in the SAT, performance on the SAT is highly correlated with the effort that a person has put into preparing for the SAT. So if that is, and that is true, and if that's true, then it's no longer measuring aptitude, all it's doing is measuring preparation. That's very much like the claim, in a sense, that students are admitted to this institution based on their JEE score, which on an assumption is measuring some sort of inherent quality of the individual's intellectual capability, and yet we know that that's not true. We know that lots of people who have been coached for several years on the JEE do better than somebody that supposedly is smart and hasn't prepped for the JEE. So what the JEE measures is prep for the JEE. Now, I'm less familiar with the work on IQ, but I'm pretty sure if you gave out what the IQ test looks like, then you could find that scores on the IQ would be closely related to preparation for the IQ exam rather than anything. So I think for the notion that that measures anything inherent about the individual is no longer accepted.
Could it be part of EQ?
So now we have emotional question.
So if you are metacognitively higher, you have a better EQ. So you can actually self-assess, you can analyze. Would that work, in your opinion?
So I would suspect that if you did the work, and I haven't seen the work, my suspicion is if you did the work that higher metacognitive abilities would be correlated with higher EQ, again, because you're monitor a lot of the stuff. But EQ is one of those things that it's kind of tricky. On one hand, they say that it's measuring something. On the other hand, they will say there are things that says they will promise to increase your EQ. So if it's measuring something, and then we can also develop it, I'm not sure that what we're measuring isn't just more practice. Okay? And metacognitive would talk about how you practice. Whoops, he says the talking stick.
So, are there ways to measure metacognition?
Yes.
Okay. And it's perfectly okay if EQ, IQ, or metacognition increase. That's not a problem.
Yeah.
Okay.
Okay. But I would say, for example, that some colleges in the US have stopped accepting SAT scores as an entry requirement or an entry criteria, because if the only thing they're measuring is whether the kid prepped for the SAT, then and the SAT doesn't highly correlate with your success in college, then why would I use it? So, yes.
Yeah, like the SAT and the JEE, we have, perhaps you're aware, a GATE called Graduate Aptitude Test in Engineering, which has been going on for many, many years.
Yep.
But I think most of us have come to know that it has no correlation or relationship with aptitude for engineering.
That's right. As far as I know, nobody has developed a measure for aptitude as if aptitude is something inherent. In fact, I don't believe that. I don't believe the assumption that it's something inherent. Instead, I believe that is intelligence, EQ, aptitude are things that you can work on and improve. They're not just inherent qualities like she's smart and you're not, and that's never going to change. I don't believe that's the situation. And that's one of the things that sometimes holds students back, is the belief that somehow their intelligence is fixed and they can't do anything about it, and so they just have to live with whatever results they get. He has stick and you don't yet. Yes, sir.
So my question actually goes to what you just mentioned. it's a little open-ended. Can we be very optimistic that if we really incorporate metacognition in a strong way into our curriculum, then the next generation of kids will be will become experts much quicker than much faster than it took us to become experts at anything?
So I think the answer to that question is a qualified yes. There has been a significant advocate for metacognitive or self-regulated development at Louisiana State. If my memory serves me correctly, her name is Sandra McGuire, and she worked in the chemistry department, I believe, initially, and she has worked a great deal with students emphasizing aspects of metacognition and self-regulation as a way to be more successful in college. The key in these things is that what you are after is not change in knowledge, but change in behavior. So for example, we will talk in a few minutes that the research clearly shows that spaced study, spaced reinforcement of material, that is, things over time, spaced with empty spaces in between, are much more effective than putting it all together. So both Josefina and Maya then may be equipped with that knowledge, but you then may still choose to display it and say, no, well, I'm going to ignore the research and just continue to cram. So it's one thing to have the knowledge. What you're really after in work on metacognitive development is translating that knowledge into behavioral change, which is a slightly harder problem than just knowledge delivery. So it's one thing to say, I'm going to tell the students that spaced repetition and reinforcement is better than blocked repetition. It's another thing to figure out strategies that are going to actually result in behavioral change. Yes?
Yeah, I can't help but compare this with Carol Andreck's research on mindset.
Yes.
And she calls fixed mindset versus growth mindset. Yep. So I guess the growth mindset would probably come under the metacognitive
Well,
approach.
both of them come under metacognitive. One actually has to deal with bad metacognitive and the other dealing with good.
Okay.
But, yes, but both things. And what he's referring to is her work talking about this idea of intelligence. So I don't know how it is in India. I've not followed it. But in the United States, you see this prevalent reference, repeated prevalent reference to the idea that intelligence is something that people get apportioned. You get intelligence and you get a lot less of it, and you get a lot more of it, and and we talk about it like that. And that language is destructive because it's wrong. I mean, intelligence is something that can be developed, something that can be nurtured and developed, and that's a growth mindset. So underneath a fixed mindset is the belief that nothing is going to change my allocation of quote-unquote talent. I mean, and that's, you can believe that and then act on it, unfortunately. Or you can say, no, talent, intelligence, whatever, aptitude, are things that can be developed and nurtured and gotten better at. I just have to be willing to work at them. Two different beliefs are going to result in two different kinds of behavior. So yes, so part of what you are doing is trying to say that people's metacognitive knowledge and behavior should be a growth mindset. That is, they're something that I can get better at. But this research is saying that it's worthwhile investing because getting better at it translates also into better academic results in your individual disciplines. Okay. This is not intended to be something that you read, but if you wanted to follow up on stuff, you have some, and you got a hold of the PowerPoint, then you would have references available. So I'm curious what people would say to this. If you want to promote student development with respect to metacognition, what do you got to work on? So I'll let you work on that in pairs. You can start out in pairs. Fill out that list in pairs. So what are, you could come up with more than 3, but what are at least 3 things that you would do? Okay, let's see we'll take a sampling. So this is the rule for getting a talking stick. If you haven't said anything today in class, in this session, then you can get a talking stick. If you said anything, then your option to get a talking stick is off the table. I will allow you to self-monitor that condition. So what's one of the tasks that you would try to do?
Yeah, so I have the talking stick here. The other side here. Yeah, never before. One of the things that I mentioned was to give them opportunity to fail.
Give them opportunity to
fail.
Fail, okay.
So that they can learn from the experience.
Okay. We give them lots of opportunities to fail. Do you want to qualify that? Now hold it. Don't leave him. Because we give people lots of opportunities to fail. Do you want to qualify that?
Also, maybe formative assessment.
Okay, so can we give them opportunities to fail where their failure doesn't count significantly against them?
That could be an option, yes.
Okay, good. Okay, then who else has a talking stick? Yes, sir.
Yeah. So one way is asking them various approaches of problem solving in the exams.
Okay.
And second one is thinking.
You get one. You get one. So I will tell you something that I tried one time. So I had a remarkably compliant group of students to do this exercise. But we had an evening exam. Okay, and the reason that I scheduled it in the evening was to go along with the recommendation of not having time test or tested to. So I wanted to provide a very good block of time where I didn't think the time would be the limiting factor. So we had the test in the evening. And with time not being a limiting factor, I gave them the test, and then I asked them to put down their pen or pencil and not write with it. Just put it down. And curiously enough, all of the students agreed. And I then asked them to just look through all of the problems on the test, page through the test, and look at them and kind of say, okay, do I have a handle on whether I can do this one or not? Do I have a handle on can I do this one or not? And I thought that would be a good thing for the students. So I thought, look at it overall, get a sense of the land. I thought I would be helping students. I tried that once. I would never try that again in my life. Why was that? Because everybody's heart, you could just tell, without heart rate monitors, everybody's heart rate was going through the roof. They go, I'm supposed to take this test and you won't let me write with the pen, and I'm looking, I'm ready to go. See, I opened this problem, but I know how to do this problem and I want to take the pen and write. Oh, it's just terrible. You could just read the anxiety and the tension, and you thought that people were all going to have these were 19, 20-year-old kids. These people thought they were going to all have heart attacks right before my very eyes. And I go, I ain't ever doing that again. But I just thought it would be a good idea if they got an overview, so forth. But no, it didn't turn out to be a good idea. So it's a good idea to have people have a problem-solving strategy or whatever. I just found that asking people to look at a test and develop those kind of strategies, ideas, before they started to work on it seemed to be counterproductive in that particular example. Next, talking stick. Yes? Okay.
Trying to solve the same problem with the students.
Okay. Model as carefully as you can how you think they would go at it instead of just how you as an expert go at it. Be as transparent as possible about your problem-solving approach. Yeah. Somebody else? Yeah. I can't keep track of the talking stick there.
Give open-ended assignments. Open-ended assignments where there could be multiple ways of solving the same problem.
Okay. Open-ended assignments. multiple ways. Okay, yeah.
We can give solutions of different people to between them, distribute among themselves to correct and see what different solution of the other person has come into their solution. And then use this as a...
Yep, let people see different solutions. By the way, I'm a big fan. You've already talked, so you can't get a talking stick today. I mean, there are many problems with this, but I had a colleague who routinely had his students in his class grade the homework assignments. In other words, he made up the key to the homework assignment, and when the homework assignments were turned in, he took the batch and gave it to the first student in the row and said, grade them and turn them in by there. And then he proceeded down. And part of the reason was that in the process of grading homework assignments, the student would see a very large variety of approaches to how to solve the set of problems on the homework assignment, which overall was a plus. Yes?
We will give them some solved examples, some solved problems, and then ask the student to create a similar problem and then solve it.
Oh, okay. Okay, good. So we guess we got one more here.
This is something I've done in the past, is give them a wrong proof and ask them to find the mistake.
Ah, okay.
And possibly construct counterexamples using that.
Okay. Wrong proofs and find the mistakes, okay. Now we'll move into the next one. So generally people have in mind the idea of transfer of learning. Transfer of learning is, by the way, transfer of learning, I've talked with Sechin about this. The most prevalent occurrence in an engineering curriculum is that students don't appear to transfer their mathematical knowledge from their mathematics courses to their engineering courses. Now, I don't know how it works at this institution, but at a couple of institutions that I was at, you'd see examples of the following pattern of conversation, non-productive pattern of conversation. Engineering faculty, the students can't do X. Math faculty, we taught them X. Engineering faculty, the students can't do X. Math faculty, we taught them X. Okay? Pattern repeats ad infinitum. Didn't turn out to be very productive in terms of creating any substantive and constructive change. And to me, I think both of the people, the problem is in that situation, I think both people are correct. The engineering faculty member is correct that in their class, the student doesn't seem to be able to do X. The math faculty is correct as they can point to and probably actually did teach X. The problem is transfer. They learn to do it in this context, maybe even with a certain set of symbols. There is some work that says that if you give a student an integral in terms of X and they're able to work it out, and then if you give the student that integral in terms of S, they fluster. That would be an example, by the way, of near transfer, where the context isn't that much different, but it's still sufficiently different that it causes trouble. So a change in symbol, change in context, that is, many times the math course is taught in the sense where the emphasis is on the abstract. We're supposed to see the pattern in terms of symbols with the idea that if we see the pattern in terms of symbols, when it comes time in a more applied context, we'll be able to say, oh, I've seen that pattern and I can make it work. But apparently what happens is the student no longer sees that pattern, the symbols are different, the context is different, and goes, oh, I don't know how to do that. And so the math faculty is correct, they did do that. The engineering faculty is correct, they can't do that. And it comes down to this issue oftentimes of their ability to transfer context from one context to another. When I say that, and near context means that the contexts are pretty similar. Okay? Far context means that the contexts are fairly different. Really far context means Nobel Prize. If you look at the Nobel Prizes that are awarded, you often can find very related research where what has happened is we have transferred the recognition of this pattern very subtly and put it to work over here. So transfer is not to be taken lightly. So far transfer occurs far less regularly and routinely than near transfer, but near transfer also has problems. When I say that people are bad at transfer, every time in every example in the literature where people have actually asked the participants in the study to demonstrate transfer, they routinely, or the majority of them fail. They don't get it done. In some issues, in some instances, the only thing that the researcher needs to do is to say, we showed you this in this context. It's a little less direct than this, but they mentioned, you saw this in this context. Could it be used in this other context? And in that case, the likelihood of transfer goes from around 30%, at least in this one case, to 70%. With all that was necessary was kind of like the prompt or permission. Yes, what you saw over here, you can use over there. And I use the word permission quite deliberately because sometimes people think, well, it works over here, but that doesn't mean I can use it over here. And sometimes even the minor suggestion that, well, maybe you could, that triggers it enough. Okay? But there are several studies that demonstrate the difficulty that people have making transfer. And yet, as I said before, the notion of transfer is what underlies our whole idea of education currently. A substitute to that doesn't rely on education is called the apprentice system. If you want to learn plumbing, you go to a master plumber, you hitch yourself to the master plumber, and you work with the master plumber, and after a while you know plumbing. That's kind of the opposite of transfer, which is if you want to know plumbing, then go practice plumbing and do it lots. The idea of an education is that I can do this, and then once I'm doing this and I'm pretty good, then I'm able to transfer it to lots of different contexts. And that has the challenge that only if the people will actually do the transfer. So I'm curious. If you had to work on transfer at IIT Bombay, what sort of things would you suggest they try? I'll give the pair another couple minutes to come up with strategies that they would put in place to improve the ability of the students to transfer. Okay, we have the same ground rule. Ground rule is if you've talked previously today, you have lost your opportunity for a talking stick this situation. What are tasks that people would propose to improve the transfer of learning? Yes?
So I teach microscopy. So this is the way how I do. Supposedly I introduce a concept to the class, and after explaining to them the concept, I tell the students to dig certain papers relevant to the topic. They read that, and just as you said, that in groups or in many groups, they discuss their idea, what they have read in the paper. Is this a good method of transferring the learning? Because they understood the topic, they understood the concept, and now they are trying to understand it better by digging papers and then sharing the idea in the class and exchange of ideas and information, what they have gathered?
So I'm not sure that it's a good idea. Okay. And I'm not, again, part of part of my difficulty says that you keep using and saying they have understood.
Yeah.
So I still can't tell, I mean, from that description, I can't tell what they're able to do and what they are enabled to do based on your instruction. They have clearly done a lot of good things. Mm-hmm. What I'm not sure is what you have enabled them to do. So, when you asked if it was a good thing, I can't give you a definitive answer.
Okay.
Maybe we should have course projects towards the end. So whatever the student learns can apply, and the student can transfer the learning to some real world project kind of a thing.
So I'll give you some feedback on engineering. I don't know your area. Electrical engineering. Engineering is filled with requirements that there's some sort of capstone project. Okay. My own personal opinion is that that should be radically changed. Okay. And the reason is the following. The whole emphasis is built around one capstone project. Okay. What you really want is somebody that can demonstrate repeated success at projects. And so I would say that you would arrange the project so that they would do one project, and then in the second project, the things that they're going to do in the second project, you would require that they be significant improvements from the first project. So my concern is if they worked on the second project, they'd just repeat the same mistakes and the same successes, and they wouldn't have any new learning. So what I really want in the second project is for them to take particularly what didn't work in the first project and say, we're going to not do that mistake again. We may make another mistake, but we're going to try something different to succeed in the second project. I don't think that the capstone project is a bad idea. My concern is that locking onto one project and judging success in that is considered great, when really we want the student to be successful in multiple projects, in multiple contexts, which is what the essence of transfer requires. And so I think that there should be actually more projects in engineering curricula rather than fewer projects, but that runs counter to the increasing emphasis that there is more content to be covered, and so we need to devote more courses to cover more content. So I'm not always sure that the first project helps. It may, but it would be good if we could see the transfer from one project context to another one to get even more greater likelihood that when they work on a project after graduation, we're likely to see success because they've succeeded at least 2 different projects. That's good. Yeah. Good. And then you look at what you did earlier and get reflection and say, what are we going to do different the next time around? Yeah. Mm-hmm. Other ideas? Some people may feel like I can't because I'm constrained by the rule, but yes.
So when you're designing your problem statements and assignments, you could word it as an application based. For example, when you're teaching a maths course, the maths problems could be somewhat related to engineering application, different fields from different fields.
Okay. You could always look in the math problem. I mean, by the way, if you want to drive scores on the math exams down, then you take whatever symbols were being used in the instruction and you just change the symbols in the tests, and you will guarantee to get lower scores. Okay. Yes, but you're right. If in courses we encouraged and said, let us show you, and we're only going to work on exams and so forth that are applications that are different than the ones that we've covered in class, that would encourage transfer. And it would also encourage negative student comments because they would say that the exam problems are not like the homework problems, which is the whole nature of, yes, because we're working on transfer. Other contributions? Yes.
I mean, after explaining one concept in the class, often I ask my students to do the Google search, like the particularly YouTube search, and post the interesting videos on our Facebook group.
Okay.
And then there we get like the lot of different application of the similar concepts.
Okay.
And then some of the students just post the idea, the video, and that's it. But like some of the students post the video as well as write the description, so that helps the others also to understand.
So if they were going to do that, I'd then get your students to then process the posts and say, what is the learning that we're extracting from these different posts? I think there's somebody in the back that is just now recognizing that there's a class going on and is going to decided to contribute. It's way back there.
So I teach...
The speed of light and sound has taken a while to reach the back of the room.
So I teach large classes, and the way I do it, basically I put very small problems, and I ask students to work it out. And those who solve it, I ask them to come to the board and do it.
Okay.
Doesn't matter, even if it's a large class. It takes 2-3 minutes of time, but it works very well for me.
Well, good. Okay, I will give you, we have one more example. Yes. No, I'll be quick. You can take your time if you want.
So I just wanted to share something that I do, which I think I've heard feedback that it's appreciated, which is I not just share the idea that I'm trying to convey, like the physics that I'm trying to teach them, but I also often tell them two things with that. One is the structure in which that idea sits. I think that makes it much more transferable as well, because immediately they appreciate, oh, causality is the underlying argument, and I could take that elsewhere, and and I could carry that elsewhere.
Yep.
And the other is I also share with them many a times my confusions with the thing as I was learning them, because I think that helps them, open up and talk about their confusions. But it also, I present common pitfalls as my confusion sometimes, because sometimes they were. And so both of these, what they do is they remove the obstacles towards the transfer of information and transfer of the learning that they have from one place where they've learned it to other parts of the system, essentially.
So I think what's happening, partly what's happening with the idea that you mentioned with causality in the first example, is that you are encouraging them to reorganize their knowledge around this idea that we're talking about. So it's one thing for a student to give you the definition of the idea. It's another thing for them to use that idea to completely reorganize how they have stored their knowledge, which is not an overnight kind of thing, but to me what you're encouraging is to say, see this principle, see how it works over here and over here and over here and over here. Think in your own situation. How many situations can you now classify according to causality? And so now they have a different organization of knowledge, and they're more likely when they see another thing to say, oh, yeah, causality is the way I recognize in the pattern causality. So I'll give you a different approach to this that an engineering educator tried. So they were working in an engineering mechanics class, and he often had the students work out problems. But he decided, no, that's not what I want. Instead, he pointed them into a textbook and said, see problems 1 through 10. Okay? I'm not interested in you solving problems 1 through 10. I want you to write out he referred to it as a script. Write out a script. So if you saw any of problems 1 through 10 or variants, this is how those problems would be handled. And he had them write out a script. So, if you see this, take this thing and put it here. See this, take it here. So he was asking them to condense down and say, what's the pattern? And when you see that, take that piece which should go here, put it here. Take that piece which should go here. Write the script down for how you're going to solve it. And then he graded the script instead of the individual solution. So that was one of his approaches to getting students to transfer, was to look at a set of problems and extract a script which could be used to solve the entire set of problems. With that, we will break for 30 minutes, and we will resume, at 4:03. This group is set 1 from this aisle over here. this group from the camera to the aisle is set 2. This group is set 3. This group all here, you're set 3. So, now, if we are going to develop instructional approaches for metacognitive learning, then hopefully you are already beginning to think that, well, the first thing that we should do if we're going to develop instructional approaches is to have what? Learning outcomes. Okay, we shouldn't design instructional approaches that are just hoping that we get there. So, I have given this task to groups of faculty members and been disappointed with the results. So I say, well, this seems reasonable. Generate learning outcomes for student metacognitive development. That seems a reasonable kind of thing to do. If we're going to work on metacognitive development, we ought to have learning outcomes. However, when I've given that task to faculty members, I've been disappointed in the results. They seem to flounder. We don't seem to get much traction. So there is, I don't know if you've heard of this word, but in that case, when you find yourself in this situation with the students, what you're trying to do is you're now trying to scaffold. You're trying to reduce the complexity or the difficulty of the problem to the point where it's more likely that you can get students get traction. And then, and if they can get that far, then we get at the next step, they can get that far. So the one way to look at it is, if it's this bridge, so if we look at this bridge, this actually turns out to be a pretty big gap for faculty to tackle. So what we try to do is to say, well, no, we're gonna get them this far, and then hopefully then they can span this gap. That's an example of scaffolding. Okay. So so I thought about trying this, and then I go, well, no, that's been too successful. So we're going to try something different. So this is a scaffolded version of the problem. I have said, okay, instead I'm going to say, let's pick a specific level in Bloom's taxonomy. Okay, and even further, the first task that you have to do is, instead of writing the learning outcomes, let's just remind ourselves what sort of verbs apply at that level. So let's first focus on set 1. You guys are set 1. You're going to get the remembering level, the remember level. Okay, so if you're going to generate student outcomes at the remember level, what are verbs that characterize student learning outcomes at the remember level? Recall. So, okay, 1. What's another one? Define. Yep. List. Okay. State. Okay. Identify. Okay. Those are all verbs at the remembering level. So set 1, I'm going to set you to work in pairs or however you want to split the work up. I would encourage you to work together so that you can share stuff. But verbs, you got define, identify, list, state. Okay? Think of those kind of verbs, and then then the requirement is that you attach on stuff and say, what are they supposed to identify? What are they supposed to list? What are they supposed to define, or whatever, with respect to metacognitive work? And that then gets those levels. Set 2, you get the understand level. So at the understand level, what are the verbs that we're thinking of? Describe. Construct is usually... Depict, maybe, yeah. Illustrate, yeah. Explain would be a very common one. Illustrate, yeah. So we've got describe, depict, illustrate. So you guys, set 2, now see how we've scaffolded this? All we have now, all set 2 is required to do is they got these initial verbs, and they can add some more at the understand level, and then they all have to do is put the nouns in and what they're looking at. Set 3, you get the apply level. So what are verbs at the apply level? Demonstrate is a pretty generic one. Perform. Solve. Solve is actually yes, but I don't know if we're going to be able to solve metacognitively, but solve is certainly a verb that works. Yes. Calculate. Yes. Design works at the create level. Analyze, kind of tricky. So, but you might then, somebody might have a little computer that they could search and Google the apply level and find some verbs. And then once you find the verbs, then fill it. So your task now, set 1, generates metacognitive learning outcomes at the remember level. Set 2, generate metacognitive learning outcomes at the understand level. Set 3, generate metacognitive learnings at the apply level. If we had sets 4, 5, and 6, we would work ourselves on up. Okay? So that's your thing. Work and take a crack at that. Okay, what I'd like for you to do now, you have your list of outcomes. Set 1, yes? Set 2, yes? List of outcome. Set 3? Okay, I'd like to form groups of 3. The groups of 3 will have one member of set 1, one member of set 2, one member of set 3. So I'd like for you to get together and look at your remembering level, your understand level, and apply level all together as a group of 3. So stand up, reconfigure yourselves, and have a conversation among the three levels. And remember, if you don't know the people that you're working with, introduce yourself. Okay, could I have your attention? Now, I don't want you to disperse. Stay in the group there. But I would like your attention back here. So, I don't want you to change. You're in good physical positions. Okay. What I'm interested in now for the set 1 people, located now various places in the room, what are examples of learning outcomes that you had for metacognitive development at the remember level? Now remember, there's going to be a talking stick that needs to get distributed. The holder of the talking stick. Okay. Just one now, we don't need the whole set.
Yeah, so we were thinking of an instance where somebody would have to recall some formula. So maybe the learning outcome could be when you teach them that either they come up with some mnemonics or acronyms that help them sort of recall better.
There's a whole story going on there. I just need the learning outcome.
So identify some mnemonics when you learn something in class.
Okay. Just give me some mnemonics that will help when we're trying to remember a list of X. Okay, what's another one?
Identify errors.
Identify
errors.
I'm sorry, okay. Errors?
Yes.
How are errors metacognitive?
It's I don't have an explanation for that.
Okay, good. Identify errors. Next.
Identify a list of identify strategies you could use to check whether your answer is correct. For example, dimensional analysis, limiting cases, and so on.
Just because I know that engineering faculty members are often very interested in estimates, sometimes we're just happy if they'd look at the thing and go, gee, did I get a reasonable answer? So strategies for checking reasonableness. Okay, what's another one? Set one, yes. It's back there.
List all the different situations like where a particular concept is applicable.
Okay, one more.
Identify where they need help in solving a problem.
So I think that's a metacognitive strategy. I'm not sure that they're actually, I think the word identify is not, I think it's actually sitting at a higher level, but it's a good metacognitive. So we're going to put it in there, but so I think they're actually having to do a whole lot more than just remember. So even though we've used the word identify, I think there's some deeper idea going on, and maybe a different verb would characterize that. But we're going to say that that's a wonderful kind of idea. Okay, so set two, what are some examples of metacognitive development at the understand level? This guy needs a talking stick or...
Yeah, explain a concept, illustrate with an example similes and comparisons, and depict or rewrite in one's own words. Illustrate with an example, similes and comparison.
Okay, now I think that that is not metacognitive. I think that that's very focused at the subject level, because you're asking them for a concept.
Right.
And that would be subject level. So you're getting them to do understand at the subject level, not the metacognitive level.
Okay.
But you got the right level. We're just focused on, we're still focused on concept, not the meta level.
So take a mathematical theorem and its proof and explain how it actually runs through an example.
So I don't think we're getting metacognitive here. I think we're very focused on, again, the subject level. In this case, it's how to use a mathematical proof. So I think both of those examples are good at the understand level. I don't think we're quite getting to the point of giving you a metacognitive learning outcome. Okay, another crack.
So explain the principle behind several solved problems.
So I still think you're, again, focused on the content level. We're being broader in the sense that we're asking them, you're saying, take several solved problems and see how they connect together, but we're still working, we're synthesizing information. And in fact, so in some ways, I think you're doing some organizational level or analysis level by saying, what are the commonalities and differences among these different solved examples? But we're still working at the subject level. So try to remember sometimes that even though you use the verb, so we got the explain verb, but just using the verb doesn't always mean that you've chosen the right verb for the situation that you're trying to describe. Okay, set two, understand level, metacognitive level. Yes?
Deciphering similarity and dissimilarity between two or more number of models.
Like that? Okay, again, I think we're trying to, okay, so I think we're having trouble here because we being subject people want to focus on the idea of subject. Now, the idea that people are working on is that they're trying to be a little more inclusive of their subject in terms of thinking things, but they're still working at the domain level and not moving up to the metacognitive level.
How about metrics?
I don't know who's got the talking stick.
Yeah. Metrics, using metrics? Explaining, like, you know, there are the metrics that you can use to see if it's a valid kind of a thing.
Ah.
That kind of a, you know?
that I know it's the plant cost is 6 times the equipment cost. You understand what I'm saying?
Like that?
Yeah. Using metrics.
Using metrics.
Yeah. There are lots of metrics in that we use.
So we're a little closer there. We're going, look, we got any kind of answer in any kind of domain, and we're saying, okay, we got an answer. Now we're asking people to jump up a level and say there are probably metrics available. Instead of suing, instead of using. I'll get to you in just a minute. But we're now looking and saying, instead of identifying strategies for reasonableness, we're explaining how we check it out. So we're making a little more, we've bumped up to the understand level, but we're now still focusing on this idea of how do we know that the answer that we're coming up with is reasonable, compatible, valid in this case. Yes, you have something.
So if I modified our example saying identify or explain the common strategies used in several mathematical proofs.
No, I still think you're working, you're taking mathematical proofs and you're saying things. Now if you said, now if you're thinking about mathematical proof, you could then say, explain how a mathematical proof might be examined to check its correctness. So now we're going, oh, there could be any mathematical proof here. What are kinds of things that I'm going to look for to check correctness? Now we're beginning to bump up above above how to do mathematical proofs and so forth. And we're now trying to say, for the whole set of mathematical proofs, what are things that we look for to check correctness or to check, possibility of problems?
Validity of a proof.
The validity of proof, or more likely in mathematical proofs, what are things we would immediately check that are likely to occur as errors? Because, it's easier oftentimes to find problems with a proof than it is to find the correctness of it. Common, that would be, what's a list of common fallacies in mathematical proofs? Yeah, that would be, but if that would be identify, and now we want to explain how to use those fallacies when you're looking at a mathematical proof. So you'd have a list of fallacies, that's the identify level, that's the remember level. Now explain how to use those. Okay, because just because we can remember the names of the fallacies doesn't mean that you can put them to work. So explaining how you put them to work is that next cognitive level. Okay. Yes, sir.
Identify.
Now that's going to be the.
Okay, but the 3 most important descriptors with reasoning.
Okay. Or describe descriptors. Okay, now if you just say identify, now we're down at the remembering level because we just have to get the descriptors. But if we explain how we're going to use them in terms of reasoning, now we've bumped up a cognitive level. Good. Okay? Now we're beginning to pump there. You got it? No, you're not. You're set 3.
I said 3.
So we don't need set 3 at the moment.
It's okay.
You might just stay there because I think we're going to move on to set 3, so you get first crack there.
Here is really the generator of things. So anyway.
Okay.
So you might as well do it. No, because we came up with only 1.
Okay. So what's?
No, but this is a little confining to a domain. So we looked at. Can we give it through an example, or it should be?
Well, the example won't be the outcome. It'll just be kind of what we're hoping for.
So if you teach a concept A, then where a very similar concept is used in some other domain. So give a problem to solve in the class, which is in domain B, where you exactly are using concept A in the. So I'll give you an example. So let's say I'm teaching digital control. I talk of convergence of, closed loop convergence or open loop convergence. So I can relate it to something in numerical analysis and say, look, iterative calculations actually converge in the identical way, and so eigenvalues play a critical role. So I could give a problem to solve in another domain while I'm teaching digital control. I give a problem to solve in numerical analysis in the class. So there's a transfer of.
So again, when you're focused on the particular example of convergence, it says, you would say, here's an example, convergence. I can put it to work in digital control. I can put it to work in numerical analysis. Now, if we move it up a meta level, it says, okay, show how, which is close to compute, show how you would use a concept in any area in another one. Yeah. So now we've bumped it up to a meta level and said, look, anytime you see a concept in one area, what are you going to do to put it to work in another area? Now, regardless of the concept, what are your kind of things that you use? That's a meta level kind of thing. Okay, where you get away from the concept and you begin to say, look, I can maybe put that to work for any concept. So you begin to say, well, convergence. Then you begin to say feedback. Then you begin to say, whatever. And you say, for all of those, what are things that would put that to work in one area? And then you can say, okay, what are I going to do to put it to work in another area? Okay, then we're moving it up to a meta level. As long as we're still focused on the concept, we're talking about, well, convergence can be used in lots of places, but we're still focused on the idea of convergence. If we get people to think more broadly about any kind of concept, what would we do to put it to work in different areas? Then we're getting people to try to get out of that. Okay, what was another group in set 3? Yes?
I have stolen a point from, excellent point from my colleague, Gargi. Find muddy points in a lecture.
And not generally. That is, what you would look for to find muddy points in any kind of lecture.
Yeah, but if one were to say, how do you explain how to find muddy points, then that's a task at the understanding level.
That's right. Yeah. But actually finding them, putting them, generally, okay. So, in other words, I'm going to give you a whole set of lectures, find the muddy points. Yes, sir?
Illustrate using a daily or a real-life problem and then demonstrate the working principle as well.
Demonstrate
the working principle.
That's pretty good. I still think it's a little, as long as we're not dealing with a particular working principle, then we're going to say, look, you're going to have any kind of real life problem. How are you going to find the applicable, what are you going to look for? And then I'm going to change your thing slightly, because in any kind of real life problem, there is usually more than one working principle.
Yep.
So what are you going to look at in a real life problem to extract the working principles? Now that begins to be pretty challenging at that apply level. So, in other words, if somebody brought you any kind of project assignment, that you could then say, I can tell you what the working principles are there. You would be pretty pleased if a student could do that, I think. Okay, what do we got? Yes, sir. Here we go. You pause, wait, all of a sudden 2 hands go up simultaneously. Yes?
Show the application of various interconnected concepts. Application of interconnected concepts to an engineering problem.
Okay. That is almost like the inverse of his kind of thing. His says start with a real life problem, extract the concepts. You say take a whole set of concepts and put it to work.
Yeah.
Okay?
demonstrate how you would use a particular concept using 2 examples from your discipline. So when I say concept, I'm thinking of, for example, something in linear algebra.
So
even in SVD.
Say it again, please. I missed.
Say, demonstrate 2 examples from your discipline where you would use singular value decomposition.
Now, I still think you're working at your content level. You're very focused on singular value decomposition or whatever. And so if we could take this guy out, which is the concept, and think about how are you going to show, what would you have to do to show examples of almost any kind of concept? Whether it's singular value decomposition or conservation or convergence or whatever, what do you got to do to generate examples from any kind of? As long as we get it out of a particular field, we're a little closer to being at the metacognitive level. And then supposedly they could use what they do here and say, now suppose I tell you the concept is singular value decomposition, take what you've just given me and show me how you're going to do that to get singular value decomposition applied to examples. Now, so let's compare our work in this site. So a remember learning outcome at the metacognitive level, or the metacognitive dimension, is identify strategies for retaining information. That's very similar to the suggestion we had to say instead of identify strategies, identify mnemonics. Okay, pretty good. Okay, predict one's response to culture shock. Any of our examples didn't look like that, but we came up with some good examples. Use techniques that match one's strengths. Okay, we didn't come up with something like that, but we got, okay. These, if you look, in their case, they're very focused on the individual as opposed to the domain. We, being domain people, focus on the domain. The people that put this together tend to be people that focus on the individual, the learner, because they come from a center. They're very focused on the learner. That doesn't mean that ours are wrong. That just, but again, you see the things like identify, predict, use. We've had similar sorts of verbs here and so forth.
And one's response.
One, yes. Again.
One's mnemonic. So you own it.
Yeah. So just notice in this case, they're thinking of the person, and in our case, we're thinking of generally our field or whatever. So if you look on down at this level, the analyzed level is deconstruct one biases. Again, the focus is on the individual, not always the case for things. Reflect on one's progress. Again, focused on the individual, not in their thing. And create a learning portfolio. Now, to me, I could change that and say, create a learning portfolio that demonstrates your use of a range of metacognitive strategies. So, you know, I might have this, and they say, well, here's the metacognitive strategies I used in this example here in the portfolio. Another example in the portfolio, I would say a different metacognitive strategies. Notice if I have a range of them or whatever. So, but the idea is I have to fashion a learning portfolio to show some things. Okay. Again, that's not the only choice for metacognitive to focus on the individual, but it's an example of and it also illustrates the biases of the people that put it together, because these are not, okay. In the remaining time, I'd like to focus on 2 things. One, I'd like to make sure if we're going to work on metacognition with our students, we need to base this on what the research on learning is showing us. Okay, so it would be good to review some of the principles on this. So I'm going to talk about briefly some strategies there. So first strategy is retrieval practice. The first principle is retrieval practice. This is very similar to the LTTT idea that we looked at yesterday, that we are better off working on repeated practice than we are constant explanation from another person. Okay. Now people will show, for example, that if you, for people that are really memory experts, they'll say, you know, I have to retrieve this at various intervals. And that people will talk about it, you know, I got something. Suppose you have to think of a person's name, okay? I got it. I have to think of it 10 seconds later. Then I have to think of it 30 seconds later. Then I have to think of it a minute later. Then I have to think of it an hour later. So this kind of focus on working with it, rehearsal, whatever. Second, spaced, leaving time. So the first thing is practice retrieval. Now I could practice the retrieval a lot, all within 1 hour. The second principle says, no, you should space it. Put spacing between your retrieval practices. This is similar to what we saw Maya doing. She would do it every day. She would work a look on it every day, as opposed to Josephine, who was going, no, I got Saturday and Sunday. I'm going to spend all Saturday and Sunday. I'm going to pack it all together. So we know that we should space it out. If you look further in there, you'll find that you can often help by talking about how much difference it makes. How more effective is spaced retrieval than blocked retrieval? Okay. If it's just like 2%, maybe not that. Actually, it turns out to be very significant. It's on the order of magnitudes of 3, 4, 5 times as effective to space it rather than just clump it all together. Interleave practice. First of all, now it would be good if I were talking to an audience in America because they would know baseball. So you may not know baseball, but I'll try to work on that I'll work on your background knowledge. Michael Jordan, I don't know whether you know the name or not, was a very famous basketball player. At one point in his basketball career, he left basketball and decided to be a baseball player. And he actually left and went to work, and he got on a minor league team. The big question that they asked about Michael Jordan as a hitter was, could he hit a curveball? Now, people will tell you actually that the curveball is the easiest pitch to hit. But they will say the real test of the hitter is, can you hit a curveball? So if the curveball is the easiest pitch to hit, why is the test of a hitter whether they can hit a curveball? Because they're not telling you the whole story. Okay? If I have a pitcher and I say the pitcher is going to throw you curveballs, then if you're practicing against only curveballs, that's easier to learn to hit. First of all, the curveball comes in considerably slower, follows usually a predictable path. It's a curveball. It's the easiest pitch to hit. Why is the test of a hitter whether they can hit a curveball? Because it's not. The test of the hitter is the pitcher is throwing a bunch of fastballs and can also throw a curveball. The pitcher is going to throw a pitch. Can you detect quick enough whether it's a curveball or a fastball and then adjust? Because usually what the most common pitch in baseball is a fastball. And so you're always sitting on a fastball, and then can you come off of looking for a fastball to hit a curveball? And that deals with why you want to go to the third principle of practice is, so if I had a batter and they only hit curveballs, or, by the way, if I only had a batter and they only hit fastballs, then when they got into a game, they would be a disaster because they couldn't tell the difference. This is the same story we talked about kind of yesterday when you're looking at different chapters. So oftentimes, one of the problems that we have when we move through a textbook is that we move through it, we do everything on this chapter, we do everything on this chapter, and then we do everything on this chapter, and then we have a test. And the third principle is interleaved practice. It's just like the curveball. What you want in batting practice is for the pitcher to throw curveball, fastball, curve, and for you to, oh, now I begin to tell the difference. So if you were going to do chapters 4, 5, 6, and 7 before the test, then you might pick a different strategy of going through that. You would go as quickly as possible, and let's do chapter 4 quickly, chapter 5 quickly, chapter 6 quickly, chapter 7 quickly. Now that we got an idea, let's go back. How do we tell whether it's chapter 4, 5, 6, or 7? Can we move through the chapters again? Can we move through the chapters again? Can we move through the chapters again? Okay, you're going to move the pace more rapidly through the chapters. The students will often say, ooh, this is uncomfortable. We're moving through these things a little faster than I can grasp. But the issue is not grasping 4, 5, solid, 6, solid. It's, I got to deal with all of these at some point. So I better start learning to deal with all of these concurrently and figure out how to switch between them. Because when it comes to the test, they're going to give me problems from chapters 4, 5, 6, and 7. And I got to figure out not only how to solve it, but I got to, first of all, figure out which one it comes from so I can then begin to trigger which kind of process do I need to work on. Ought to encourage interleaved practice. That is, moving between things rather than always focused practice, which is, we're only going to talk about this, we're only going to talk about that. And that comes back to the canonical example of the curveball. This is, okay. So the third practice is interleaved practice. So most faculty are pretty good at encouraging spaced practice. You'd be better off studying for the test 2 weeks in advance, doing a little at the time. Less rarely used is interleaved practice. Fourth practice, elaborate. This is the idea that we talked about when they asked the instructor asked them to do a script. That is, when you work on a problem, I don't want you to solve the problem. I think one of the talents we have when the students solve a problem at the end of the chapter is they think they're supposed to solve that problem. You don't actually care whether they can solve that problem. You know what? No, you don't care. What you care about is, can they solve the next problem? Which has elements of this, but you don't care. Yeah, this problem's been solved. The answer's been worked out. You know, they got an answer key. You don't care whether they solve that problem. But the idea is that we will work on this problem with a mind toward being able to solve the next problem. But we often position it as, let's just solve this problem. That's not what we're after. We're solving this problem as a practice to looking at the next problem. With that in mind, you might approach the solution of this problem differently. What are we going to look at in this problem? And if we gave them a whole set of problems, what are we going to look at in this set that we can begin to filter so the next time we see a problem, we'll be able to solve it? Because a common complaint about students is, I solved the homework problem. When I got to the test, it didn't look like the homework problem. Now in your picture, it looked like the homework problem. That's because you look at it from the view of an expert. They look at it view from a novice, and this is how a novice organizes stuff. And you're puzzled beyond belief. What were they looking at in the homework problem that they can't see that the test problem looks like that? Because they're trained to, they don't know. They don't know what to look for, so they can look for a lot of surface things or whatever. You know that this next problem, then the test looks like it because you know what to look for to make it look like that. To them it looks different, to you it looks the same. You want them to be prepared to look for the same. So elaboration, another strategy is ask more with the idea that what you're working on is not, you're not interested in the solution to this one, you're interested in the solution to the next one. This is again the case of the capstone. You are not interested that they can do the capstone project. You're interested that because they do the capstone project, the next project they work on, they'll be really better off. Okay, fifth one, generative. This is the whole essence behind problem-based learning. Problem-based learning says, before I give you any theory, and this tends to fly in the face of how we structured academia, before I give you any theory, I'm going to give you the problem and ask you to kind of tackle it. Attempts to answer a question or solve a problem or whatever before being shown the relevant information makes you more open to the information that's coming down the pike. Because you go, oh, wait a minute, now I've tried to tackle this. Now, they may not have made huge progress, but now they're going, oh, if I get some stuff that helps me to answer this thing, I'm master for it. Instead, we give them the whole theory or whatever, and they're kind of looking and going, I wonder what do I do with that? So, generative learning, where you give them stuff to work on and then later follow it up. Reflection, this is the opposite of, almost the other end of generative learning. Reflective learning is after we've been through something, after we've solved a problem, after we've solved the test or whatever, gee, what did we take away? Okay, plus deltas, minute papers, so forth, are all attempts to encourage, are examples of attempt to encourage reflection. Now that once we've been through something, what did we get out of it? And finally, calibration. Calibration, seventh principle. Okay. This is kind of a key to self-assessment. If you say to students and say, okay, there's a test coming up next week. We have been through the material. How well prepared do you think you are to succeed on the test? They will give you judgments. Okay. Oftentimes, those judgments, unfortunately, are overly optimistic. Why is that? Well, it's because you haven't quite posed the situation correctly. You've given them a very broad set of thing, and they could think of, well, yeah, I worked on example 4, and I could do example 4 really well, so from there, so you don't know what they've seized on to make their judgment. So calibration is the part of going through and saying, okay, how well do you think you're going to do on the test? And when you give me your judgment, I want 5 examples to support the case that you've just made. In other words, if you say you're going to do really well, show me several examples that support the case that you're going to do really well. If you think you're going to do poorly, why should I believe you? So calibration is getting some way to make a judgment and then ask and say, well, how do we, what are we judging against to improve the accuracy of our self-reflection? What are we actually judging against? What are we aligning with? How do I make my measurement tend to align more? Okay? And the last one is mnemonic devices. These tend not to be as valuable for the disciplines we're interested in because we don't tend to want retrieval as much as we want application. But again, those are all well-supported principles for learning. Those are all, many of them, contrary to what how our students approach learning. It would be good if our students knew the principles and talked about how to apply them and how they go about learning in their studies. Okay. For the people that follow up with this, and they go, where are the evidence for the retrieval effect, retrieval practice, also called the testing effect? Yes, sir.
Is there a hierarchy in these methods of learning?
Hierarchy on what principle?
In effectiveness of retaining information on the side of the student. In effectiveness of what we want the students to do.
I think it relates to the cognitive level that you want them to perform at. So mnemonic devices for solving problems, pretty useless. Interleave practice for solving a test is really very important because the test is going to have several problems on it, going to come from several different places, so interleave practice would be important. I would think generative practice is real important. That is, we do not want to give students theory. What we want to do is to say, here's a problem. How would you go about it? Have them take some cracks at it and then go, okay, let's now talk about some stuff that might be able to help us. That would be probably a lot more effective. the spaced retrieval would always be good. And, the testing effect, the LTTT, as long as they're focused on the problems that we want them to look at. So, among, if I take out the mnemonics, all of this other set really could be, unified together in some sort of, in many sorts of how would an individual put these to work for their particular thing. Okay, I am going to wrap up. I would like, so you don't have to, if you don't, we could just end now, but I'd like to share something that I think is a really interesting kind of idea. If you're willing to listen for about 15 minutes, then I'll try to do that.
Okay.
So I'm going to tell you, generally our work is divided into two areas. We are interested in process and content. Now, I'm not going to be too specific about what those mean, but in my experience, when I do that, people kind of have an idea. And if we say that we are interested in process and content, we may have people who are good at content, and we may have people who are low at their ability on content. We may have, on the other dimension, we may have people that are high on process and low on process. And so that gives us four kinds of people. Kind of people, number one, low content, low process. We are not too happy with those people. Okay? On the other hand, high content, high process, we have everything that we wanted. We are really happy with those people. The other two quadrants we're a little unsure about. If I told you we had high content, low process people, how happy are you with those people? Versus if I told you we had low content, high process people, how happy are you? So these people have coined some words. Low content, high process people, that may have caught your attention, are intellectual amnesiacs. They don't know anything, but they can put their learning to work very quickly. So if these people were interviewing for a particular position and they would ask them information about the position, they would be really poor. On the other hand, if they got hired, they might be able to learn that position very quickly and become proficient. These people, on the other hand, if they've interviewed for a particular position and they had that high content, they might look pretty good. But then as soon as they got hired, they might not show off 6 months down the road because they would be asked to learn new things, process, and they're low process people. I got down my content, I just can't put it to work in anything else. So, we don't have any trouble distinguishing between these two. We have a lot of trouble figuring out between the others, which we prefer. So, this is the situation. At the end of a university education, we want high process, high content. We're pretty sure about that. And we're pretty sure that the people coming in are low process, low content people. Okay? So we're pretty sure of the starting point. We may have some vagueness here, but we're down in this area. And we're pretty sure of the end point. The question then becomes, what kind of path do we follow that is most likely to get us to the point up there as quickly or as efficiently as possible? Now, the blue path is what the typical university education is, because if you look at our curriculum, we pile on the content, and then at the end we put in this capstone course which kind of integrates things together and works on process. On the other hand, if you go to the other extreme, this would work on a lot of process and then go content. So then the question becomes, which path is more efficient toward getting us to our desired end goal? And the real question becomes, are there any studies that we could use to justify the argument one way or the other? And I've got one. Now, to show you the study, I got to do a little bit of a twist on this content process thing, because they use different words. So instead of content, they use efficiency. That's people that did the study, they use efficiency. And instead of process, they use innovation. So low efficiency, low content. High efficiency, high content. Okay? Now, in those quadrants, we're going to give them different names. We're still low efficiency, low content. We're not too happy with these people. High efficiency, high innovation. That sounds good. So, and then we have the things for the other two quadrants. Now, sometimes I look, and I show this, people go, oh, we want this. We want this. We always want this. Well, let me suppose something. Suppose in an unfortunate situation, you have a heart attack and you need a bypass. Do you want a routine expert or do you want an adaptive expert? Yeah, most people, you're going to say, wait a minute, I want somebody that's done this like 100 times and is not going to say, gee, this is a chance for me to try something new. I'm thinking, I don't want that guy. I want somebody that's done it 100 times and he goes, I'm just going to repeat that very successful process 101st time. I want a routine expert. So while universities say we want adaptive experts, in many cases there are situations where we just want a routine expert and we're pretty happy with that. Yes, sir. You got to wait for the talking stick.
It isn't working. I'll just be loud.
Okay.
So with the previous
Yes.
adjectives, with the previous adjectives, the bottom right looked more attractive than the top left.
Uh-huh.
With the second set of adjectives, rudderless and overwhelmed looks underwhelming.
Yeah.
So are they equivalent?
I think they're in the same position. You can characterize them as slightly, and you're right. So the adjectives give you a different picture of the thing. So I think this may exaggerate something, and the other one, there might be situations where you would really want to hire this guy. Now, the rudderless and overwhelmed might convince you that you don't, but if you look at what this person can do there, you might want to pay attention to that. So I use this because that's the article, so forth. But these people use the terms innovation and efficiency, and I want to introduce that because that becomes important in terms of how they're setting things up. But I also want to say that this relates very similarly to the process and content format that most faculty begin to talk about. So, as a matter of fact, these people, this adjective now gives you a slightly bit more positive point of view of this. If we look at this author, he uses the term intelligent novices. Okay, gives you a kind of, novice still suggests they might be a little rudderless and they might get into situations that overwhelm, but they actually bring something to the party. Okay, now, they did some experiments to see whether an innovation first or an efficiency first learning experience moves students to adaptive expertise more rapidly. Okay, so we actually ran an experiment. We didn't run a 4-year university curriculum based on everything. We actually just ran kind of a small-scale experiment. But I think it's a really interesting experiment. So if you sit. Yes, sir.
About the same, okay. I'm a little confused whether we are talking about the same thing in these two charts. I mean, innovation, efficiency, and content and process. So, I mean, are we talking about the same things, or are they two different charts altogether, really?
So they are using two different words, two different sets of authors. This chart comes from one set of authors. This chart comes from a different set of authors. However, I think if you look at the text in the articles and look at how they're describing those words, I think you would see them more tightly connected than the use of the word suggests.
Okay.
But I'm using the words that the author uses so that if you went to the article, you'll say, these people don't use the word content and process. They don't. But if you look at how these people are using the word innovation and efficiency, they're very similar to how the earlier, more academic-oriented article would use process and content.
Yeah, so are we
That's
trying
my argument.
No, what I meant was, so are we linking or are we likening efficiency to content here?
Well, I think, no. So I'm likening efficiency as these authors use this word in this situation. There's a completely different definition of efficiency over resource out or over resource in. That's not their idea of efficiency.
Okay.
I think it comes...
So the way we understand efficiency right now is more like content. I mean,
the way these authors are using efficiency is much more like the way we use the word content. They're really good at particular things. Now, so this is the experiment they want to run. Now, this is how they ran it. Okay, first we're going to create two sets of students. One set of students, we're going to give them content. The other set of students, we're just going to give them process. Okay, this gets complicated because we're going to eventually end up with 4 sets of students. And so a little easy to keep track of. But first, how did we do that? Okay, the subject matter is statistics. So the content people, they talk about grading on a curve. They get a procedure for marking deviation regions on a histogram. They get practice in computing means and standard deviations. They get stuff thrown at them. Just, it's a lecture. They get to practice some things. I mean, it's not like they didn't do any kind of hands-on things. The innovation people got almost nothing, except, they got data. They got data on high jumpers. High jumpers had cleared these various heights, various number of times and so forth. And they got pole vaulters. Pole vaulters had cleared this height various number of times. And they wanted to know, okay, here's a new pole vault thing. And here's a new high jump thing. Did we actually break the record by a big amount or a small amount? They just got data, numbers, and they were asked, I want to know how much was the record broken by a lot or a little? That's all they were doing. They got data, they got that question, they played with it. There was no class presentation, no sharing of solutions. The students just worked on the answer. They got no feedback, okay? So it's about as process-oriented as you can get. Okay, then we tested them. Okay? One group got a post-test. They both got post-tests. One group got a worked example to go along with it. To say, here's a problem. Here's a worked example. Might be related to the thing. Other group got same problem, no worked example. So it's very much like having an exam problem with a resource, exam problem without a resource. Now, because I had 2 entering sets of students and 2 exam procedures, I got 4 sets of students. Of those 4, only one showed higher performance. The group that showed higher performance was the group that got their process stuff. They got process instruction, and they got the test with the worked example. They were up here. The other 3 were down all about the same group. So you go, I would have thought that the people that got content instruction would have been better off. We gave them a lot of the stuff they were going to need to know to work that exam problem. Neither one of the content people did outstanding in terms of the exam problem, whether they had a worked example or not. Curiously, the process people did just about as well on the exam problem with no resource as the content people, which may strike you as strange. But when those people got a resource that they could reason with, they did better on the exam. So I'm going to suggest to you that this Now, I actually thought that this was a very interesting way to attack things. Thank you very much.
So Jeff, we would like to thank you for coming all the way from OSU to take this wonderful workshop. This is the first big event that our center is conducting. And I think this was really, really a wonderful experience. First of all, we should appreciate Jeff's stamina. Talking for 6 hours requires, and then interacting, discussing requires some energy, and hats off to you. This was something really. So I think Jeff needs a standing ovation, and this was really a wonderful experience, and thanks a lot for coming all the way for us. So we are all your students, and we hope you will come back again to guide us in the future. If anyone wants to share something, please let me know. Otherwise, we can split.
I'm not saying this for the sake of using some words, but I do not think in my 26 years of teaching at IIT Bombay, I have taught something to my students which they can use today. What you have taught to me yesterday and today, I'm going to use in the class that I'm teaching now in this semester. Thank you so much.
Thank you, sir. Can you also guide us on typically what happens after the workshop? How do we take it forward? I mean, do we do something together or individually? Or how do we interact with other faculty who have probably done learning outcomes exercises or other methodologies?
So the first thing I would try to do is to organize yourself. I got this question earlier. I would try to organize yourself as a group that's going to meet somewhat regularly. I know with faculty schedules or whatever. But if you don't continue to talk about this and work with it, the likelihood that it will influence you long term is lower. The fact that this gentleman says he's going to put it to work right away suggests that some of it will last. But for many of you, if you don't continue to think through the things and talk about how you apply, we're in that kind of learning curve where, oh, we may be out here, but we'll fall over quickly. So I would try to look together to see how you can meet on a somewhat regular basis. And the meetings that I suggest would be to work with the people in the center and say, okay, please recommend a couple of articles for us that we will agree to read in advance. And then we'll come together to talk about how we would put the learning from those articles to work in our class. And that conversation may last an hour or two, whatever, but I think repeated doing that would get you accustomed to seeing the literature that you can put to work in the class, and then seeing what your other colleagues are doing and how they're transferring the research on learning and teaching to their classes. So I would encourage that kind of ongoing interaction.
So I just wanted to say that this is for Sachin and me, this is the second course with Dr. Freud. Yep. First one was at IIT Madras, and in fact, we did just the learning outcomes part there. And after we came back in the electrical department, we were reviewing the undergraduate curriculum, and I realized that we had been doing just as you know, we had just been listing topics, and now we are putting learning outcomes for everything. So that is already happening, and we are happy to share our experience, and I think the center provides just the platform to do that. I would also like to thank Sachin and Mrinal for organizing this workshop. Thank you.
Thank you very much for all the data and the reasoning you've given us to support active learning. As final thoughts, could you maybe focus on how do we help the weakest students in the class?
Generally, so two ways. So I would try to find the weakest students and talk to them about the learning strategies that they're first putting into place. And then I would bet that the learning strategies they had put into place are almost diametric opposites to the learning strategies that we see are supported by research. And I would say, okay, here's the learning strategies. Can we develop a plan for you to apply those? Two, I would try to put them to, let's see, this becomes a little more complicated because you're going to ask students to work in teams. And I've tried to illustrate that getting students to work in teams is a level of complexity higher than just kind of trying think, pair, shares in classes. But to the extent that they work in teams and you get the teams to realize that each of the members of the team have very productive things to contribute, even though the weaker students don't look like on one dimension, maybe content-wise, they are in a position to make strong contributions. Generally, people find after a while that they really provide a very valuable perspective. They can often get people to see that the way that they're expressing a concept is not clear. And when they ask again for the explanation, you know, they go, somebody goes, okay, maybe I can make it clearer. And so the act of the team working with the people can bring their kind of, if you want, process perspective together. But in the process, they find, everybody on the team finds that their learning is increased and improved. So to the extent that you can get those two things done, they generally will really help those students. The first one works on a little more individual basis, and you can imagine the next one, working in a team, requires some skill and knowledge on the part of the faculty that are trying to get them to work in teams, because you know, everybody looks at those students and goes like they're the last ones picked to join your team or whatever. But if the team is gets a picture of the fact that working with a more diverse group of people really can in fact strengthen the learning of everybody, then that team can really pull together and pull everybody up, surprisingly. So those are the two strategies that I know tend to work together.
So I would, of course, first like to thank Sachin Patwardhan and the Center for an excellent workshop, and, you know, Professor, for you, for the time and the energy that you've spent with us. It's really very impressive. And what I must emphasize is that, you know, even after such a long span of teaching, there are so many things that one sort of takes for granted, or one also probably misunderstands when we teach students. And there are a lot of things here which sort of presented a perspective, which was, I use the word iconoclastic, with, you know, for example, when you talked about all the 4 levels with all the 6, so that was very interesting, you know, and one would believe that. So I think it's been very, very illustrative and very, very revealing, what has been presented, and I'm hoping to be able to use this in my teaching, and I'm also probably hoping to use it in my guidance of students. Because, you know, it's not just for teaching in a classroom. I can see that some of these things probably also apply to student guidance or student supervision. So, thank you.
So if you are supervising a group of PhD students, you may be considering, how do I get that group of PhD students to work more effectively together as a team? And so you could look at the material on teams and say, what can I apply from there with respect to my research group, so my research group begins to function more like a team and less than a set of individuals.
One possibility, of course, is the group of PhD students, but the other possibility, which also happens quite frequently with us, is whatever you might call it, a pyramid, if you want to call it that. So you have a PhD student and maybe a couple of master students and a couple of undergraduates who all work together to, you know, with, of course, with distinctive tasks, but then there is an interdependence and which results in an R&D outcome. So that's also one domain where I see this diversity and in unity and diversity kind of thing play a role.
Yeah, so this has set us thinking completely in a different path, and I hope we will continue this and continue to meet, and will serve as ambassadors of change in different departments. Thanks a lot.